I decided to perk up my metal notcher and get the registration fingers accurate. The tool I have appears to still be available from MSC. As I recall, this cost me about $250 back in the day. It goes way back to my first shop when I was doing a lot of production work. Some jobs were very price sensitive, so I needed to find ways to improvise and cut costs without compromising quality. Imported tools aren't all bad, but usually suffer from inaccuracy problems. With a little TLC, these problems can be corrected and you can make accurate parts while saving money. This video shows how I corrected inaccuracies with just a little time and effort. The hardest part was lifting the rotary table up on the Bridgeport mill. It ain't easy on the back. Here's my notcher. You've probably seen this in a lot of my videos. I bought it about 25 years ago and it was a hand crank job, and I added the hydraulics on here. You could see that slave cylinder. Over here, here's the pump. So this machine was made in Taiwan. It's an imported tool. It's not bad. It's worked pretty well. When I had my other shop, I had to do like thousands and thousands of notches, so I got a little sick and tired of pulling on the handle. So these fingers that are the registration fingers that hold the metal in position, these edges weren't parallel, and this wasn't a 45-degree angle, which is typical of imported machinery. They're a little sloppy with how they do things, and this is burped up a little bit. You might be able to see that there. Probably about 10 or 15 thousandths. It's not a big deal. You know, those pieces should be taken out and they should be milled down so everything's flush, but to be honest with you, it's a very, very minor thing. It's not worth the effort. But the notcher works pretty well. So I finally, after 25 years, decided to true these up. This one's finished, so I got this one done. The other one's work in progress, so I'll show you what I did on that. Got a little carried away one year, nipped off the corner, so this is now a stop. So, you know, that kind of stuff happens from time to time. Better that than nipping off a finger. So anyway, let's go over to the Bridgeport and see what's going on over there with the other finger. Here's the setup on the Bridgeport. Probably the toughest part of this job was lifting this rotary table up and getting that set up, but I've got that rotary table set up there. That gives me my 45-degree angle, and my Kurt milling vise over here. Kind of see the whole setup here. So it worked out pretty well. I've got one more finger to do, so I'll show you what's going on with that. And 3/8 inch end mill holder in here. Pretty standard stuff, pretty basic stuff. So that's how the setup works, and let's get into what I was doing with that, getting that finger squared away. All right, this piece, as I had mentioned before, has already been done. It's not that exciting, it's pretty straightforward. The first thing you want to do is just clean your vise at the bottom, make sure there's no crap and grease and stuff in there. Set this piece in, and then just nip off a thousandths here, and just keep taking off a thousandths until you get a completely machined surface. Flip it over, do the same thing on the other side, and that'll get this surface and that surface parallel. So just to prove that out, let me change this tooling out and let's indicate this top surface. And the tricky part is the 45-degree angle, and I'll show that in a little bit more detail. Okay, there's the dial indicator set up. Hopefully you can see that. So we'll go ahead and indicate the top surface. Got a little bit of an angle on the probe there, so that scale isn't exactly reading as it's calibrated to read, but you can see that for the work that this piece is going to be used for, this is really pretty good. There's very, very little movement on that indicator. So we just, like I said, machined off a thousandths till we got all the metal removed. Flip this over. Same thing on the other side. So this surface is now straight and it's parallel with the other surface. So that's all we were hoping to do. So let's take a look at the angle on this, see what's going on with that. Okay, here's the setup. I put the finger down on the rotary table. I got to hand hold this, so hopefully nobody has to reach for the Dramamine. But okay, so we've got this zeroed out, And if you indicate near the center of the table, you can rock this table back and forth a couple degrees and you shouldn't see any appreciable change in the indication. So the goal here was to get this edge parallel. So let's crank on it and see what happens here. So we're running down along the edge. It's pretty good. We don't have to really go any further than that. Again, apologize for the wiggly camera. I'm hand holding this. Okay, so the table's got a little bit of slop in it, so we pulled that out and we're zeroed out right there. This dial is 4 degrees per rev, and I zeroed out here, so we've got 97 degrees here minus 45 is 52. So what we're going to do is we're going to crank on this dial here. We want to go around 11 times for 44 degrees and then 1 more degree for 45, and we should end up back here at 52. So let me take care of that and see how that turns out. Okay, so I went 45 degrees. I locked the table down. That's what that knob is. You could probably see that there. We're at 52 degrees, which is as expected. And then here, that 3, since we're going backwards, it's 11 turns plus 1 degree, which is 4 back to 3. So that's 45 degrees. So if this is actually accurate at 45 and will indicate this edge, we should see no deviation in the indicator. So I got to set that up, and then we'll indicate along this edge and see what we get. Okay, we got the dial indicator set up, and the table's locked down on this side and back on this side, and then the actual dial, you can see here, that's all locked down. So we got the indicator set up at 0. Let's crank on this and see what's going to happen. Again, apologize for the shaky camera. You can see what's going on here. We're out almost 7 thousandths. That should be dead nuts on. It's not that bad, but you know, it's not right. So the next part of this is, let me change out this dial indicator, get an end mill in here, and then we'll go ahead and touch this surface up and get it true. Okay, here's what we got going on. I put a little cutting fluid on the edge there. Just go ahead and shave this off here. Just a conventional mill. Come back. Let me reset this and take another thousandths off as a finish cut. Okay, we took a final cut of a thousandths as a finishing cut. I sanded the edge a little bit to smooth it up, so we can re-indicate this. I don't know if you can see that. Again, apologies for the Dramamine camera, but that was off 5/6 thousandths, maybe 7 thousandths, and you can see it. It's pretty much dead nuts on. You know, that dial indicator has been around for quite a few years, so it's probably got a little slop in it, but I'm happy. It's pretty good. So that takes care of that. A couple things that you might want to be careful with when you put this down on your table. Obviously make sure that the work overextends the rotary table so you don't cut the table when you mill the edge off. Now, it might sound stupid, but they're easy mistakes to make. So anyway, this piece is done. Both sides are done. They're true, they're straight, they're parallel. We got a 45 on the miter, so we're good to go. So thanks for watching, and I hope you enjoyed this video.